In exercises 39 through 42, the derivative of f prime of x, a differentiable function, is given. In each case, find the intervals of increasing and decreasing for f of x. Determine values of x for which you have relative maximum or minimum occur. Find f double prime. Now, I did find f double prime for you, and it's there. Determine intervals of concavity for the graph of f. For what values of x do inflection points occur on the graph of f of x? There is something that you have to be careful about that they're not telling you. What could it be? Because they haven't given me the original function. What is it about f of x I need to be careful about as I look at the two derivatives?
Where it's undefined.
Where it's undefined. Right? The question is x equal 1 a vertical asymptote? That makes a difference. They didn't say anything about that. Except I have an x minus 1 squared. What's the likelihood it's a vertical asymptote? It is, right? Bring the denominator up, times the derivative of the numerator, minus the numerator, times the derivative of the denominator, all over the denominator squared. So if x minus 1, the original, you do quotient rule on it, what are you going to end up with? An x minus 1 squared. It is very likely that x minus 1 or x equal 1 is a VA. Because with that squared in the bottom, how did it get there? It got there because when you do quotient rule, an x minus 1 becomes an x minus 1 squared. They didn't mention that, did they? Am I going to have to take that into account? Yes. Because it's not going to be a max-min, and it's not going to be an inflection point. It's a vertical asymptote. Bad author. They do that to play with our minds. Right. So here we go. We want to know, we're now going to be dealing with, and I think I'll just break this down the middle here. F prime. We want to know where f prime equals 0 or f prime does not exist. F prime equals 0 where x plus 2 equals 0 or x equal negative 2. This is multiplicity 1, so we know it changes. And the minute you say it changes, you know it is a max or a min. Does not exist is where x minus 1 squared can't be 0, x can't be 1. This is multiplicity 2, so there's no change. But we have now established that this is a VA. So it's not going to impact increasing or decreasing at all. And it's not going to impact max-min because there's no change across 1. Where it's going to hit us is going to be in inflection. Where it could nail us, let's put it that way. So now I draw my number line. And I put on negative 2, change. I put on 1, I'm going to leave that open, and I mark that as a VA and there's no change. Otherwise, if I don't mark it as a VA, then I'll think it is something that's not supposed to be. And plus, I learned my lesson from being smacked many times. So now I can put in my favorite number, which is x equals 0, as my test point. And my test at 0 plus 2 over 0 minus 1 squared. That's a positive divided by a positive. So positive, change, negative, no change, positive. So negative followed by positive means I have a min. So I've got a min at x equal negative 2. It's increasing from minus 2 to 1 because it's a VA. It's not in the domain, so you've got to jump over it. 1 to infinity. Decreasing from minus infinity to negative 2. And of course, increasing and decreasing doesn't include the critical number. So I think we've answered that question. Okay, f double prime, we want to know where f double prime equals 0. F double prime does not exist. Well, x plus 5 equals 0, x equals negative 5. This is multiplicity 1, change. Now, because we have a change, we know x equal 5 is an inflection point, correct? And x minus 1 cubed can't be 0. X can't be 1. We've established this, well, this is multiplicity 3, so there is a change across there, but we also know that it is a VA. So you've got to change the concavity. You're going to move from concave up to concave down on either side of the VA. So now on our number line, negative 5, and our VA, which is at 1. Everybody changes. Pick my favorite, x equals 0, and I look at 0 plus 5 over 0 minus 1 cubed. That's a positive divided by negative 1 cubed is negative. So this guy's negative. Change positive. Change positive. Now, see, if I didn't know that was a VA, I would think that's an inflection point. See, that's why I got myself into so much trouble when I was a student. I forgot to put the VAs on the number line. Because I would pick up answers that weren't answers, you know, which is like, well, that's a VA, well, that's an inflection. But no, you forgot your fact it was a VA. Ah, yes. So I got in lots of trouble with vertical asymptote. Lots of points. So now, what do I know? I know this is concave up followed by concave down, right? So this is an inflection point. So I have an inflection point at x equal negative 5. And then we're looking at concave up versus concave down. So concave up from minus infinity to negative 5, and from 1 to infinity. Any place I have pluses. Concave down from minus 5 to 0.